Before understanding this concept, we have to understand the Markovnikov rule. Markovnikov was a Russian scientist who made a generalization in 1869, right? He was a scientist in 1869. Markovnikov gave a generalization to explain the addition reaction of hydrogen halide across the unsymmetrical alkene. He states a rule. Which is known as the Markovnikov rule, which states that the negative part of the addendum, that means the adding molecule. For example, if we are taking HBr here, so it is the addendum, right, adding molecule. So the negative part, that means negative part is bromide ion here. So the negative part of the addendum gets attached to that carbon atom which consists lesser number of hydrogen atom. That means the negative part attached to the carbon atom where is lesser number of hydrogen atom. So the product A which we have formed here, it will be treated as the major product as per Markovnikov rule, right? So to understand Markovnikov rule, we can understand its mechanism and we can better understand the Markovnikov rule, right? So I am taking the mechanism. See, you have to remember one thing. I am telling you, you have to remember one thing. Rich become richer, right? And poor become poorer. Okay, you can remember this only. Rich become richer. So here in case of hydrogen, the carbon, which carbon atom is more rich? This carbon is richer, right? So this will become more richer. That means hydrogen again attached to this which have already have more number of hydrogen, right? Rich become richer. That means here already it consists more number of hydrogen atom, and again when we do the addition with respect to HBr, then again hydrogen add to the carbon which already have more number of hydrogen atom. So if we check the mechanism of this reaction, let's start. So this is propene. When we do the addition with HBr, first of all the H plus part, right? We do the reaction with H plus. There will be possibility CH3, CH2, CH2 plus, right? That means if we add this hydrogen here only, then there will be formation of 1 degree carbocation, right? If I do addition to this carbon, then there will be formation of 2 degree carbocation, right? This one. So as we know that secondary carbocation, that means 2 degree carbocation is more stable as compared to 1 degree carbocation. It is less stable. So it is very clear, that means the possibility of formation of this compound will be more. So when secondary carbocation is formed, then this will be the product. That means 2-bromopropane. So this will be treated as major product, while CH3, CH2 and CH2Br, this is treated as the minor product, right? There will be formation of both the compounds, but there will be possibility, that means major product will be 2-bromopropane, while 1-bromopropane will be the minor product. And this is the actual thing which Markovnikov rule states, that the negative part of the addendum will go to the carbon which has less number of hydrogen atom. That means hydrogen, in reverse we can say that the hydrogen will attach to the carbon which has more number of hydrogen atom. You have to remember that thing. Okay, now come to, I think this is clear to everyone, I think. Now come to the next thing, which is anti-Markovnikov rule. We have one more rule, and anti-Markovnikov rule. See, I think I try to complete the whole alkene in a single video. So I am taking all the topics in a single video. So anti-Markovnikov rule, which is also known as the peroxide effect. It is also known as the Kharash effect, right? Kharash effect. So anti-Markovnikov rule, as the name show, that means which is opposite to the Markovnikov rule. Markovnikov rule states that the negative part of the addendum go to the carbon atom having lesser number of hydrogen atom, and this rule states that when we use the peroxide, when we do the addition reaction of HBr only, okay, this is applicable for HBr only, when we do the addition reaction of alkene with HBr in presence of peroxide, that's why it is known as the peroxide effect, then it follows the anti-Markovnikov rule. And this was discovered by MS Kharash in 1933, that's why it is also known as the Kharash rule. So if I am taking CH3 CH double bond CH2 and I do the reaction with HBr and I am taking presence of peroxide R2O2 here, then there will be H go to the carbon where is less number, that means the opposite of the Markovnikov rule takes place. CH3 CH2 CH2Br, yani 1 bromopropane will be the product. So this is the major product when we use peroxide. And again I am telling you one thing, that this rule is applicable only when we add the HBr, not for the reaction when we add the HI or HCl. So I am taking its mechanism here for more understanding of this rule. This mechanism undergo the free radical mechanism. So here as peroxide I am taking benzoyl peroxide, right? So in first step I am taking benzoyl peroxide and it undergoes the homolytic fission, right? Homolytic fission, through homolytic fission we will get free radicals. This one, we get 2 free radicals. Now this is again, this is unstable, so it break from here, so we will get phenyl free radical, right? And 2 molecules of CO2 will release from here. Now in second step, the phenyl free radical react with HBr, which is present in the reaction, and it also undergoes the homolytic cleavage. C6H6 benzene is formed and bromine free radical is formed, right? Now in third step we take our reactant, which is an unsymmetrical alkene. Bromine free radical attack on it, right? And again there is possibility of 2 product. One CS3, we do the, if bromine attached to this, then the 1 degree free radical is formed. If bromine is attached to this one, then 2 degree free radical is formed. So as we know that 2 degree free radical is more stable as compared to 1 degree. So this will be the major product. It is the major product. Now in last step, we just add HBr again, it's homolytic fission. H add to this compound CS3CH2 CH3. Yes, plus Br. I think I missed one thing here. Just a minute. CS3CH CS3Br. Sorry, this is CH2 here. Yes, this is, sorry, this is 1 degree. This is 1 degree, and I think I have done some mistake. I'm taking it again. I think I have done some mistake here. So the reaction is CH3 CH double bond CH2 plus bromine free radical. There will be possibility of CS3 CH CH2 and Br. One possibility is this, right? That means Br attached to here, so this will be the free radical 1 degree, and the second is the that 2 degree. Yes, and it is more stable. This is less stable. So now the last step, CS3CH CH2Br. When treated with HBr, again it's homolytic cleavage, then hydrogen attached to this CH3CH2 CH2Br, and Br free radical release. So this is the major product. This is the major product, and the other one which is formed through the 1 degree free radical, it will be the minor product. So in this way, anti-Markovnikov rule takes place with the addition of HBr in presence of peroxides. Now the fourth reaction is addition of S2SO4, sulfuric acid. So sulfuric acid, you can write, the simple way is you can write in this form, H plus HSO4 minus. So if we do see H2 and we react it with SO4, then simply we will get CS3 CH2 HSO4 minus, right? In this way we will get the product. So the name of the compound is ethyl hydrogen sulfate. Ethyl hydrogen sulfate is the name. Now the next is the addition of water. In addition of water, this addition of water takes place when we take some acid. In presence of acid, we do the addition reaction. Simply we can write in this way, HOH. Again use the Markovnikov rule. H go to the carbon where is already more number of hydrogen, so negative part of the addendum go to the carbon having lesser number of hydrogen atom. So this will be the product, right? Now next is the oxidation. We do the oxidation. In oxidation takes place by using KMnO4, and we can use the KMnO4 in 2 ways. If we use the dilute aqueous solution of KMnO4, if we use the dilute aqueous solution of KMnO4, which is also known as the Bayer's reagent, right? So then we will get the vicinal glycol. Vicinal, that means the at the adjacent position, glycol, that means 2OH group will be attached to the adjacent carbon atom. So if I am taking the case of CH2 double bond CH2, and if I do the oxidation with KMnO4, right, dilute cold KMnO4, that is the Bayer's reagent. I am taking 273 Kelvin temperature here to show that it is cold, right? Dilute cold aqueous solution of KMnO4, then it is treated as H2O plus O. because this is aqueous, so it gives water molecule as well as it is oxidizing agent, so it gives the oxygen. So this H2O, it gives 2 OH in this way, right? And these 2 OH, one attached to here and second attached to here, and this will get converted to vicinal glycol. Here it is ethyl glycol. Vicinal, that means adjacent position. At adjacent position there will be 2 OH group, right? Now if we take unsymmetrical alcohol, again the same kind of compound will form, same reaction takes place, only the product will be different, right? The process will be same again. So again vicinal glycol will form in such a way, propane 1,2-diol will form, right? But if I am taking the case of acidic potassium permanganate, acidic KMnO4, right? Then it also oxidizes alkene, but it oxidizes alkene to ketone or acids. It depends on the nature of the alkene, right? So if I am taking the case of CH3, I have CH3, CH double bond, CH, CH3. In this type of KMnO4, acidic KMnO4, you have to remember that every carbon gets converted to CO group and H gets converted to OH group. So from here it break up and it will get converted to C get converted to CO, and H gets converted to OH. That means CH3COH, and in the same way for this CH3COOH. That means 2 molecules of CH3COH, 2 molecules of ethanoic acid will be formed, right? So this is the one example, and I am taking one more example because these are very important reaction. If I have CCH3 whole twice C double bond CH2, and I am taking this reaction in presence of acidic KMnO4, right? Again breaking from here, CH3 C CH3 double bond, that means ketone is formed, right? Carbon gets converted to C double bond O. The carbon across the double bond, and that is only gets converted to CO, and hydrogen attached to that carbon gets converted to OH. Now CH2, in CH2 C gets converted to CO, H gets converted to OH, again one more H gets converted to OH. This is an unstable compound. Here it releases H2O and CO2. So what will be the byproduct? CO2 and H2O. So we generally write CO2 and H2O whenever CH2 is present in any alkene and we do its acidic KMnO4 oxidation in presence of acidic KMnO4. So we will get a mixture of ketone, CO2 and H2O, right? Next is the ozonolysis. Now, ozonolysis is simply, it is the addition of ozone. It is simply the addition of ozone, right? So if we have any alkene and we do the ozonolysis, then you have to remember that 3 atoms of ozone will add across this double bond in such a way like they form a hut-like structure, right? They form a hut-like structure. Now this intermediate which is formed here, it is known as the ozonide because it is formed from the propene. So propene ozonide. If it is from the butane, then it is butane ozonide. And this product is, this intermediate, this product is unstable. So when we react it in presence of zinc and water, it break in such a way that it will get converted to aldehyde or ketones. So CH3, CHO and CH2O. CH2, that means you can write it HCHO. CH2O means HCHO. The actual form is HCHO. So we get a mixture of ethanol and methanol here. You can do the same reaction by using different products, different compounds, sorry. So if you take this one, I'm taking this one, see what will be the product. CH3, CCH3, addition of ozone molecule, ozonoid is formed, Zn plus H2O, breaking from here, CH3, C, CH3, double bond O, this double bond O and CH3. So a mixture of aldehyde and ketone is formed, right? I think this is visible to all of you. Now, remember the most important reaction is related to the addition of HBr, which is according to Markovnikov and anti-Markovnikov, and the ozonolysis. These are the very important reactions. Now the last reaction of the ethene. I know the video is too long, but this is, I have prepared this video because I want to complete the complete top. I have to complete the whole topic in single video, right? So last reaction is the polymerization. So polymerization, that means the addition of small units which are known as the monomers. They combine together and form a large molecule which has higher mass as compared to that small units, and that product is known as the polymer. So if I am taking CH2 double bond CH2, I am taking n molecule of it, and I am taking high temperature. I'm taking high temperature and pressure. I'm using catalyst here. So if I'm taking n molecules, see, it means CH2 plus CH2 double bond CH2 plus CH2 double bond CH2. That means n molecules I have taken. Then the bond will shift to this in this way, and it will get converted to a large molecule which is known as the polythene, which we use in our daily life. This is polythene, right? And in the same way, if we use propene, then we will get polypropyne. If we use butene, then polybutene. Polymers, we can say that polymers, these are generally used for the manufacture of plastic bags, right? Bottles, dishes, toys, pipes. In such a way, there is a lot of use of the polymers. So this is all about the alkene, and I hope you all are able to understand the topic. I tried my best. So thank you so much for the video. Thank you.